Title: Graphing Rational Functions such as 1 over x. Learning objectives: to understand graphing of 1 over x. 2. To understand vertical asymptote, horizontal asymptote, slant asymptote, hole, y-intercept, x-intercept, domain, and range. These are the 8 points that we need whenever we're graphing rational functions. Before describing the graphing rational function of 1 over x, there are 8 points I'd like to talk about. The first point is vertical asymptote. The vertical asymptote is the imaginary vertical line where a curve approaches that line but never meets the line. And that's a curve approaching the line but never touches it. This line, the vertical asymptote, is a line of x equals c, such as x equals 2 or x equals minus 2. The next point is horizontal asymptote. Horizontal asymptote is the imaginary horizontal line that a curve approaches but never touches. This line is a line of y equals c, such as y equals 3 or y equals minus 3. Slant asymptote is the third one, which sometimes is called oblique asymptote. It's a line that the curve approaches but also never touches. The slant asymptote, the word slant means slope or gradient. Therefore, the equation for that is y equals mx plus c, where example would be y equals 3x plus 5. And that's a slant asymptote or oblique asymptote. A hole, it's a discontinuous point in a curve where you draw a circle and a curve approaching the hole touches one end and then start from the other end. So it's a discontinuous point in a curve. The y-intercept is when x equals to 0, what's the value of y? And the x-intercept is when y equals to 0, what is the value of x? Domain are all the possible values for x. So all the possible value input for x. And the range are all the possible value output for y. Before I progress, let me give a few definitions. Polynomial: 4x cubed plus 8x squared plus 2x power 1 plus 5x power 0 is a 4 terms polynomial. So this polynomial has 4 terms. X to power 1 is equal to x. X to power 0 equals to 1. So if I write this polynomial properly, it will be 4x cubed plus 8x squared plus 2x plus 5. So my point is every constant in a polynomial has x to power 0 next to it. Each term in a polynomial has 3 parts. The first part is a coefficient, and the second part is the base, the x variable, and the third part is the exponent, the power or index. Let's look at x cubed. So x cubed in this polynomial has a coefficient of 4. So we write x cubed has a coefficient of 4. What about x squared? That has a coefficient of 8. X to power 1 has a coefficient of 2, where x to power 0 has a coefficient of 5. The exponent in this polynomial, the x cubed has an exponent of 3. The x squared has an exponent of 2. X to power 1 has an exponent of 1. And the x to the power 0 has an exponent of 0. The highest exponent in this polynomial is 3. And the highest exponent is what we called degree of polynomial. So degree of polynomial is the highest exponent in a polynomial function, or the highest power, or the highest index. Every rational function has 2 parts. The rational function has a numerator and a denominator. In this case, the top function I've written here is the numerator, and the bottom function will be the denominator. So degree of polynomial is 3 for that function, and the numerator is the top part and the denominator is the bottom part. Therefore, DNP stands for degree of numerator polynomial, and where DD P stands for degree of denominator polynomial. A rational function is where the degree of numerator polynomial is less than the degree of denominator polynomial. An example will be x squared plus 3 over x cubed plus 4. The degree of the numerator is 2, which is less than the degree of the denominator, which is 3. So this is rational function. A rational function is a function where the degree of numerator polynomial is greater or equal to the degree of denominator polynomial. An example would be x cubed plus 4 over x squared plus 3. The 3 for the numerator is greater than the 2 for the denominator. So that's a rational function. Where the powers are equal for both numerator and denominator, it is also an irrational function. Now let's graph 1 over x. So first of all, as I said, 1 over x is x to the power 0 and the x is x to the power 1, which is the degree of numerator polynomial is 0 and the degree of denominator polynomial is 1. And this is bottom heavy. That means the higher number is at the bottom. And therefore, this is a rational function. Because it's a rational function, the condition on the right applies. And if it's irrational, condition on the right also applies. So you need to check those before you proceed. So in this case, let's find number 1 is to find VA. This is the vertical asymptote. So the vertical asymptote is the imaginary vertical line. And in this case, in order to find it, you set the denominator to 0. In this case, x equals to 0. And that's the answer for that one. So it's a vertical line at x equals to 0. Imaginary vertical line. Number 2, find HA. Well, if you look on the right, the condition for finding HA is on the right here. If it's rational function, bottom heavy, y is always equal to 0. And that's it. Number 3, SA. Well, to find SA, if you look on the right, if it's rational function, it does not have SA, slant asymptote. If it's irrational function, it may or it may not have SA. So you have to check the condition on the right to be able to see that. In this case, it does not have slant asymptote, so no SA. Number 4. Does it have a hole? Well, no in this case, because to find a hole, if you look at the condition on the right again, at the bottom right, you can see a hole implies that they have same factor both in the denominator and numerator, and those factors cancel out. And the factor that cancel out, you set it to 0. In this case, x plus 1 equals to 0. And then you find x equals minus 1. And then you put that minus 1 back into the what's left after cancel out to get your y. In this case, y is a half. So in our situation 1 over x, it does not have a factor that has the same for both numerator and denominator. Therefore, no hole, no hole. Number 5, y-intercept. Well, it doesn't have a y-intercept because to find a y-intercept, you have to say when x equals to 0, what is y? For x equals to 0, it's a line of asymptote, so therefore it doesn't cross it, so no y-intercept. Number 6, x-intercept. Again, to find the x-intercept, you have to say y equals to 0. And what is x? Again, y equals to 0 is a line of intercept, so it doesn't cross it, and therefore no x-intercept. And the last two are your domains, 7, domain, and 8, the range, which we will find when we've plotted the graph. So now we're ready to plot the graph. And now I can sketch the curve now. I have drawn my y-axis and x-axis, and then I've drawn my VA when x equals to 0. The blue line is the vertical asymptote, and the red line is the horizontal asymptote where y equals to 0. So next thing I need to do is find 2 points, the 2 coordinates on both sides of the vertical asymptote. So in this case, when x equals to 1, what would be my y? So 1 over x is y, and therefore 1 over 1, so therefore y equals 1. So at this point here, if I trace, if that was x equals to 1, and I trace along, y is also 1, and therefore that's my first coordinate, x 1, y 1. The next coordinate is to find a coordinate on the opposite side of the vertical asymptote. So let's choose x equals to minus 1. So we choose x equals minus 1, and therefore we're going to get y equals 1 over minus 1, which is minus 1. So when x is minus 1, so that's minus 1 there, and y will be minus 1 as well. So that's your point here. So your curve or our curve is going to go like that and approaches those line of asymptote. That's it. And then on this side, it'll be coming up like that and approaches the line of asymptote, but never touches it. And that's your sketch for 1 over x. That's the curve. Now we need to write down the domain and the range. Right, to write down the domain and the range. By the way, you could have plotted more points if you wanted to, just to show how it approaches the line of asymptote. So yes, you could have plotted more points as you go along there by getting the values of x and calculating the values of y. To find a domain are all positive possible values for x. The way we write a domain, for instance, for the x axis, which is y equals to 0, you're right. We go from minus infinity, we approach 0, and then we start again from 0 and then approach plus infinity. So that's a domain for the x values. So the way to do it is to write it in formal way: x colon, curly bracket, x colon, minus infinity first, because that's the smallest part. It's less than x, it's less than 0. That's when it approaches the line x equals to 0, and then you close the curly bracket, union, u implies or, and then you start again, curly bracket, x colon, and then 0 is less than x, is less than positive infinity, and then you close the bracket. For the range, we're going from minus infinity to approaching 0, and then we'll start from 0 again, and then all the way to positive infinity. Very similar to x, except you replace x with y in this case, or fx. So you go y colon minus infinity less than y less than 0, curly bracket close, union, y colon 0 less than y less than positive infinity. And that's it. That's how you write your domain and range. Thank you.